want to make this clear to yourself and to the listeners that when Red and I discussed him coming on the show, he was told he would be given 15 minutes of uninterrupted airtime to make his best case for the spinning ball model. All I had to do was ask the younger gentleman, hold on, are you telling me that your entire argument is based on measurements that you're taking by accepting the figure that's given about a distance, the circumference of the Earth, the radius of the Earth? And he said, well, yeah, but you can do it with any measurements. You can measure this yourself. And then I said, okay, when did you measure it? Oh, well, I observed the parallax and I've got friends and we use Google Maps. And then I said, hold on, so you're saying that you did this via Google Maps? And then he said, oh, well, actually, no, we measured it in our car. I mean, his own story changed a couple of times in the space of a few minutes the moment that they were asked to elaborate on their story.
Yeah, does the base have to equal the diameter of the Earth? I'll tell you the answer. I'll give you a hint. The answer is no. Because I said at the very beginning, that when we look at the parallax, the baseline can be whatever it is. The parallax or the theta value of that object will correspond correctly to the x regardless what that baseline is. I said for simplicity, we use the baseline. If we had a distance from here to here, and it was a known distance that we actually physically went out and measured, which we can easily do nowadays, you can drive your car, set the trip, and there you go. And if you drive far enough to actually get a parallax value, you can get the same exact equations. The baseline is what the actual distance is.
Where do your measurements come from? So you say the 2012 parallax of Venus. Where did you get those figures from? Who was it who made the measurements?
Okay. I am going to repeat once again. Thunderfoot posted a video of the transit of Venus. I also took the measurements. He linked exactly where he was on Earth. He linked exactly where it was. He showed on Google Earth. We can draw the measurements there. I know how far away it is. I've been there before. Very nice place, by the way. And with the distance known between us, we can get an accurate measurement, being that on this side, my silhouette was here in this example, his silhouette was here in this example, and the angle of B is directly proportional to the angle of A, which is equal to the angle of theta, which means that when we do the measurement, it equals 1 over 60, which is theta over 360, equals 1.3 times 10 to the 4 kilometers.
Oh, I understand that you've done the observations, but your entire system going right back to 90 minutes ago doesn't just depend on those observations, it depends on the measurements between the observations. I'm asking you, where did your measurements come from? You're telling me Google Maps, is that correct?
Distance over time. Are you going to tell me, really, honestly, right here, right now, in front of these people that are watching, that the distances that are claimed to be between me and Hawaii are lied about, and that when I took my trip over there, it didn't feel like it was as long of a flight as it actually was? Because if that is what you're saying, that is one hell of a fucking assumption to make.
We're talking about big assumptions, but it sounds as though you're assuming that the distances given by Google Maps are sufficient to base parallax on, to base the rest of your arguments on, to base the speed of the Earth around the Sun. So you tell me, for the listeners' benefits, are you going to confirm that the distances that you use, the things that underpin the rest of your 90-minute presentation, you get those distances from Google Earth and from the 2012 parallax? Is that correct?
From my actual traveling from the place. Again, we actually traveled. Just like what Ziller said, I didn't get the distance from Google Maps. I got the distance from actually doing the driving. Now, sir, one can say that, oh, you can't drive all the way to Hawaii, but I've driven to California. It feels like a 2,500 mile trip. And if we were to get rid of all the wigglies in the road, you're not going to get anywhere less than 2,000 miles. If Hawaii is proportional to the diameter of the United States, and I have driven that, and which we can see happens, being that people who take cruise ships can plot the speed of the ship, and by that amount get distance over time and get to the Hawaii, we can simply add the two values together. I've done this. People have done this. Your entire critique of this depends on literally any Joe Schmo lying out of their ass.
Geometry works, but everything that you've done following geometry depends on measurements. Now, you started off by using the diameter of the Earth. When I asked you where you got that diameter from, you said you don't need the diameter of the Earth, you have your own measurements. I asked you, what are those measurements? You still haven't told me. What's the greatest measurement that you've taken distance to distance on which to base the rest of your arguments? What's the greatest distance that you guys have measured, and did you document it? These people need the gravitational constant. They don't want to talk about the gravitational constant because they know that it's hocus pocus. The silly old bugger went and mentioned, I got him on the spot. I said, you just brought up the gravitation needed for water, so you accept that you need gravity. Big mistake, Buster. How do you prove the gravitational constant? He brought up the Cavendish experiments. Big mistake. The problem is, if you're going to come into a discussion like this, it wasn't even a discussion, if you're going to come into a lecture like this with a strategy of sticking to a plan of using clever rhetoric and only arguing for a set model at one time and then another aspect of the model at another time, you need to stick to the strategy. And I don't know if it just got too late in the morning there, wherever the older bugger was, but once he got put on the spot, the whole thing went to complete and utter shit. And if I was him, I'd be embarrassed of myself.
The case that was being made with regards to Kepler's third law, Kepler's laws of planetary motion, are what we call a kinematic model. They're basically just a model of the geometry of motion. If you're to plot the path of the motion of a body through space, it's the geometry of that motion. Newton came along and gave a dynamic model, which is basically a model that explains the forces that make that motion happen. So you don't need gravity in order to set out the kinematic model. You don't need gravity to say what the motion itself is. You need gravity to explain why the motion is what it is, and it does it beautifully. Well, yes, you do understand that the model of gravity suggests that matter is attracted into the center of mass from all directions. I'm sorry, that's going to mean that material like water is going to form into a sphere around the center of mass. You can say that you don't believe in gravity, it's fine, but that's the model you're arguing against. So you can't say, oh, how does gravity hold water together in a ball? Because that's what a force that pulls everything towards the center of mass from all directions does. What if you drew arrows in 3D space, all pointing, all the same length, and all pointing at the same central point in space from all different directions? What shape would you get? A sphere. What a surprise. The geometric facts that prove the shape of the Earth don't disappear if gravity isn't what forces things to form into a ball. Geometry isn't going to suddenly fall apart because you have a problem with gravity, or, I can't prove to you that gravity exists. That's not going to affect the geometric facts that prove the shape of the Earth. This is a complete non sequitur. Why are you trying to shift away from the shape of the Earth?
Oh, on the contrary, I want to focus on the shape of the Earth. You're the one saying...
Well, so do I.
Well, you're interrupting again. You're the one saying that water curves around a ball, and you're saying that that's due to gravity. That's fine by me, because I'd like to talk about gravity. Now, you've been very cleverly and masterfully avoiding the topic of the gravitational constant.
For God's sake, no, I haven't. I'm sorry, but that is a completely disingenuous tone. I have not been avoiding gravity.
Well then, can you please explain to me how we arrived at the gravitational constant?
I know that there's the Cavendish experiment. I know that I know that experiments have been done recently and since to try and verify what the gravitational constant is with increasing accuracy. My point is that when it comes to the shape of the Earth, it's a question of geometry, not of physics, so I don't really need to touch on gravity in order to deal with the geometry of the Earth. I don't mind touching on gravity, but it just has nothing to do with the shape of the Earth in terms of the geometry of the Earth. And I think you're trying to steer it to this because you don't want to deal with geometry, because you know that geometry just craps all over the idea that the Earth isn't a ball, because it proves it's a ball.
Well, I've been very patient with you now. I've got a couple of questions for you. You brought up the Cavendish experiments. Now, these were the experiments back in the late...
No, I want to go to the geometry, please, and I want to deal with the gish gallops that are coming.
I'll be more than happy to do that, but I think fair is fair here. We've listened to you. Now, I've just got one line of inquiry for you. You brought up the Cavendish experiments. I'm glad that you did. For listeners who aren't aware, the gravitational constant that is still used by so-called scientists to this day was determined in the late 1700s by hanging two heavy balls from a torsion balance. Is that your understanding, sir? The gravitational constant on which all of your theories are based was determined in the late 1700s. Is that your understanding, sir?
No. No, just because Cavendish started the experiments going doesn't mean that we're using the measurements from that. You do realise that scientists repeat experiments, improve experiments, and continue improving those experiments and those measurements. The gravitational constant we use today is not the one that Cavendish figured out.
And how different are they? How much has it changed in those 200 years?
Oh god, it hasn't had to change too much as far as I can remember.
No, isn't that amazing? Gravitational constant on which all of this is based has changed less than 1% in more than 200 years. Were you aware of that?
Yeah. Yep, 1% down to 6.67. Which, oh wow, so great, our measurements have become more precise.
Yeah, so you don't find that at all remarkable that the gravitational constant on which everything else is based, especially to do with gravity, was determined to within 1% of our current figure more than 200 years ago by hanging balls from a torsion balance. You don't find that noteworthy?
No, considering we use different methods of doing it today that come back with the same, more or less the same result. And I'm sorry, but I want to get back to the actual questions of the shape of the Earth. And I think what you're trying to do is trying to shift it away from the geometry because you know you can't deal with it.
Oh, on the contrary, my friend, I think all night you've been...
You stay on the contrary, but you keep going to this non sequitur argument.
Well, all night you've been avoiding gravity.
Do you understand this very simple fact that the only thing that determines the shape of an object is geometry? Do you understand that very simple fact?
Oh, I'm happy to discuss geometry, but I think
it's a yes or no question. Do you accept that the only way to define an object is geometry? Do you define the shape of an object? Do you accept that's the only way to define the shape of an object?
I accept that you use geometry in your calculations, and I don't even...
No, it's a yes or no question. Do you accept that geometry is the only thing you can use to define the shape of an object? Do you accept that? Yes or no?
Yes, of course. It's a simple question. The issue
fine. Then geometry is the only thing we need in order to determine the shape of the Earth. Then let's talk geometry. Because that's what I'm here about, is to talk the shape of the Earth.
What we're trying to establish is how you know that the Earth is a sphere, and you depend on gravity to know that the Earth is a sphere. Now,
no, I don't depend on gravity to know that the Earth is a sphere. I depend on geometry, and you've just admitted that geometry is the only way to define the shape of an object.
I think they did come with a pretty clever strategy. The idea was to confound the listeners and even attempt to confound you and I and David Weiss on the panel by referring to their dynamic models and their kinetic models, or whatever term it was that they used. And the idea would be that if they can present an internally consistent model to explain what we observe in the sky, and then use a separate, distinct argument to try and argue for why we're not a flat Earth, that they could then convince the listeners that the ball Earth model makes sense. That was their strategy, and I think to a large extent it worked only because we were nice enough to give them this massive platform of almost 90 minutes to carry on with their nonsense. But the moment that we got a chance to really put them on the spot and to explain some of the other aspects of what they were saying, they went to water.